Hello friends, welcome to the video on Python list and its methods. In the earlier video which was published last week, I explained basics of list. In this video we will see what are the built-in methods for working on lists. The methods list is given here. All these methods we will be discussing and I will be explaining. So welcome to my channel Programming in Python with RSK. Let us start. These are the number of methods that are available in Python. We can find out what are the methods available for any kind of Python object by giving print dir and the name of the object name of the object we want to know the methods of this list. In this case we are using list. All the highlighted methods are discussed in this video. All other methods are difficult to include because they are not very rarely used, they are not very oftenly used. So in this video we will discuss what are the methods which are regularly and oftenly used by the programmers. All other methods we will see later on. There are three methods we are going to discuss in this slide: append, remove and pop. So we have declared a list capitals with data Mumbai, Delhi, Bhopal, Chennai. Then we use the method append for including one more name of a city, Bengaluru, in the given list. Capitals dot append and into the parenthesis Bengaluru. So whatever we want to append with is in the parenthesis, and this being a method, capitals dot append works for appending the list. When we print the capitals, we can see Bengaluru added at the end of the original list. After Chennai, Bengaluru is added. Append adds new item at the last position in the list. Again a capitals list, and we want to remove Bhopal from the list, and the method uses dot remove. When we print the list, Bhopal is now missing. We can remove desired item from the list. Now another method, another list num with so many datas or so many items, all numerals. Then we give a command num dot remove and into the bracket 29. So what it actually does is it finds out the data given in the parenthesis and removes it from the given list. So we can see 29 removed from the list, but this 29 is the first occurrence when the remove works. It has removed the first occurrence, still there is 29, but it has not removed it. It removes only one item and which occurs first in the list. Then another method is num.pop and into the bracket 5. So this 5 represents index number of the item which we want to remove from the list. So item at index 5 in the original list num after removing 29 is 77, so that has been removed. Then num.pop without mentioning the index removes the last item from the list. We can see methods remove, pop, etc. all alter the contents of the list but not the object. We have seen the object is remaining same in all the operations using remove, pop and all. What happens? Let us see and get understood what happens after to the object on which remove, pop methods have worked. So a num list with so many numerals as its content. Now we are using size of, which is a method in list. It gives us the memory location or the memory occupied by the object num. 2 underscores, then size of, again 2 underscores and then parenthesis. First print size of gives us 104, which is the bytes used by the object num, and len num gives us number of items in the list, which is 8. Then we do all these remove, pop, 5, pop without any index, and then prints the list and print the ID of the list. What we can see here is ID of all the of the list after all the operations dot remove, dot pop, dot pop 5, etc. The object remains same, only the contents are removed. So earlier the list was having 8 items in it, and now after all these modifications by using remove and pop, what we see is 5 items are remaining, but still the memory occupied by the list remains same. It's 104 bytes here, it is 104 bytes here, 8 items in the list, 5 items in the list. So number of items, even if they have altered and came down, the memory allotted to the list num remains the same. Contents alter, but object remains the same. 2448 is the ID of the object num, and that object remains same even after using remove, pop and removing the items from the list. The contents shrink from 8 to 5, but memory allotted remains the same. Memory does not shrink. Why this happens? Let us try to find out. We have declared a list A, then Python will create a object AA, which is an object which is referred by identifier AA. Actually, in Python, object of the list AA contains an array in which pointers to the items in the list are stored. So actual items are not stored in the object, their pointers are stored. The list object does not store actual values but pointers to those values. This figure can give us a better understanding. This is object A, it is having an array of pointers. One pointer is pointing to first item of the list 11 and so on. So memory locations freed by removing the contents does not remain accessible, as those locations are holding pointers to the list items and not actual value of the item. So when we saw that in the earlier slide, the items of the list are reduced from 8 to 5. So by logic, 3 memory locations or 3 bytes or more than 3 bytes depending on the value must have been freed, but we cannot access those values. Python doesn't give us any method or any way of accessing the freed memory locations, so that programmatically we can assign values to those locations. It's the job of OS and Python and not the programmer. Then there are methods insert, count and index. There is a list capitals, and then we have given a size of method. We have used a size of method and the ID. So when capitals is equal to Mumbai, Delhi, Bhopal, Chennai, the size of the list capitals is 72 bytes and its ID is 7984, ending last 4 7984. Then we insert Hyderabad at index 2 of the list capitals by using a dot insert method, and when we take a printout or when we print the capitals again, we see Hyderabad included in the list at the location having index 2. Inserts Hyderabad or whatever is the string we give here or whatever the item we give here, it inserts it at the index which is appearing as a first parameter of the dot insert method or function. On inserting Hyderabad, naturally the memory locations required to accommodate Hyderabad will be increased, and the new size after inserting Hyderabad is 104. So earlier capitals was allotted 72 bytes in the memory. On adding or inserting one more item, the memory now available or memory now allotted to list capitals is 104. We can see here the object remains same. The object do not change. Object is 17984 earlier, and after insertion of Hyderabad the object is again same 17984 ID. Only its memory occupied by the object has changed. So this is expansion of the list. List expands, objects remain the same. Now in this case num, we are using multiple int constants 1, 2, 3, 4 to 9, and then we want to insert 0 at index 3 using dot insert. So we can see 0 has been added in the list. Then there is a method dot count, capitals dot count Delhi. We can see in this list Delhi appears 2 times. Dot count gives us the number of times an item is appearing in the list. Then we use index. What does it does is it gives us the index of the item in the list which is mentioned within the parenthesis. This is index 6 at which the numerical 7 appears in the list num. Gives index of item mentioned in parenthesis, which is 7 in this case. There are two methods of reversing a list. One is reverse as a method and another is reversed as a built-in function. The effect of using this is same as far as the list items are concerned, but they are totally differently executing the reverse function in list. So a list num 1 to 10 are the items in the list. Its ID is 33984. Now we use num dot reverse, which is a method, and print or outputs num. Print num gives us reversed position of all the items in the list num. Here it was 1, 2, 3, 4 up to 10. Now it is reversed 10 to 1. What we can see here is ID remains same. Earlier 33984, after dot reverse 33984. In another case, when we use reversed built-in function, what we do is again declare a list num. It is ID is printed 15584. Print reversed num. What the output is we get is a reverse iterator object at such and such location. So reverse returns an object of the list or its iterator object, reverse iterator object, that we convert to list using list into the parenthesis reverse num. Earlier print reverse num gave us the object. Now print list reverse num give us the actual reversed list. return object is converted to list. And when we print or when we take the ID, what we get is 15584, and when we print num we get the original list 1 2 3 4 up to 10. So what is happening when we are using a return a reversed function? The list does not change, only it is rearranged in a different object which is not known to programmers or to us. It is only known to the Python. That object which is created after reversing the given list is a temporary object. It has no name because only Python wants to know it. So that object gets output, we get the output of that object's contents by this print statement. Whereas the original num object remains the same. So actually what happens is the method dot reverse changes the whole contents of the list, and the new list is the same list remains, the object remains same, only the contents are now occupying a position which is different than the original one, which is reversed now. In case of reversed function, the original list does not change. The location of all the items in the list remain the same, even though we have used the function reversed num. So in case of reversed, original list remain the same. In case of dot reverse, original list is changed or altered. Then there is a function sort and a built-in function sorted. Sort is a method, sorted is a built-in function. What it does is it changes or sorts the list and arrange it with lowest number occupying the 0th index location and highest number occupying the last location. So here we have declared a list num having ID 28064. Then when we take a print num, we get exactly what has been the contents of the num in the same order. Then num dot sort is now a method. What happens is the numbers get sorted from least to the highest value. Object remain the same, contents change. In case of sorted, what happens is the numbers are sorted from lowest value to the highest value. They appear in that order in the list, but when we use sorted, the list which is created internally by the Python is a temporary list. It has the contents sorted but actual list remains the same. Method sort alters the content of the list, whereas the built-in function sorted does not alter the list. The function sorted creates an internal unnamed temporary object with sorted list. Temp unnamed object qualifies for garbage removal once its use is over. Then we can use, here we have the sort and the sorted arranges the contents in ascending order. We can use reverse is equal to true as a qualifier, which causes the list sorted in descending order. Then there is a method clear in Python. What it does is it clears all the contents of the list. Now A is assigned with 100, 200, 300 as the contents. We have a print A which gives us those contents here as the output. The ID is again here 47104. Then we use method a.clear and again print AA, or the try to take the output of the contents of AA. What we get is an empty list. This dot clear method has removed all the items from the list, but the object is same. Here the list populated with certain items has the ID 7104. After a.clear, the ID remains same. The list contains no items. We can append another list to the cleared list here. So with a.append with this value 100, 200, 300 again as a list. When we execute, when the this a.append is executed, the list contains list contains now another list which is 100, 200, 300. So it gets appended with a list, and that list becomes the part of AA, but the ID remains the same with new data. How ID is clear, how clear is different than deleting the list. When we delete a list using AA is equal to empty list is created. Print A gives us empty list, but now the ID of that A now has changed, so the object is different. Previously, when the A was populated with certain items, object was ID was 17280 and the list ID was 17280. After clearing the list, a new list is created which is an empty list to which A starts referring to, and now A is a new object with ID 1600, what we can see here. So in both cases list is cleared, but in case of method clear, the object remains same, only the contents change, while when we assign the when we want to clear the list using A is equal to empty list, a new object is created and the earlier object is not available to us. It becomes it qualifies for garbage clearance of the Python. Then there is a method copy. We have given a 100, 200, 300 as the assigned has been assigned to a list AA, and its ID is 440256. Then we create another list BB by copying the contents of AA into it. So BB contains what I have been assigned to it by copy method, but BB is now a new object. Copy creates shallow copy. Change in one list does not change the other. Then there is another method extend. It adds all elements to the list from other iterables, be it a list or tuple or set, to the end of the given list. Again, a list AA assigned with 100, 200 and 300 at its elements. Its ID is 1920. Then we create another list BB with these three items: Rajendra, Python and programming. When we AA.extend BB, we execute this method, extend method. What happens is the contents of BB are appended to AA at the position after 300. So a new list or a new content of AA is created, having added 3 more items in it, which are the part of another list BB. What we can see here is after adding or extending AA with contents of BB, object remains same or ID remains same, 1920. AA remains same. Only thing is contents are added to AA, additional contents. Whereas when we use AA plus BB as our way of adding contents of BB to AA, what happens is now AA is containing 100, 200, 300 and then these three: Rajendra, Python and programming. Now AA plus BB again adds these three: Rajendra, Python and programming to AA, earlier AA, and when we take the ID, what we find is there is a new object created having ID 0256. In case of extend, the object remains same. In case of concatenation, a new list is created, a new object is created, to which AA is now referring. So this is all about methods of lists. Thank you for your patient viewing. If you have liked the video, please like it, share it and subscribe to the channel. Programming in Python with RSK. I also have another channel, Programming in C with RSK. I would request all of you to please also subscribe to this channel, available at channel ID Rajendra Kulkarni 7333. Thanks.